8.5 is triangle midsegment. So it's triangle XYZ. So this one inside of here is formed by connecting the midpoints of the side of triangle UVW. What is the length of XY? So this is kind of cool. What's happening is this big side UV, X is the midpoint. So this is equal to this. Here, Y is the midpoint of WV. This is equal to this. And then here, Z is the midpoint of UW. So we don't really need to know that right now, but the other connection here is that when you know this length, it's actually half of the length that's running parallel to it. So can you see how this line and this line are running parallel? So if this is 6, that means this is 3. The line on the inside is always half of the line on the outside. So I could do that for any of them. If this is 8, I would say that here to here would have been 4. If this is 6, that means this is 3, because this is actually half of that. Isn't that cool? All right, number 2, same thing. NOP is formed by connecting the midpoints of the side of triangle KLM. So this one in here can follow our properties. Find the perimeter triangle KLM. So K to L is now working from, here's my inside value, what's this outside? Well, if this is 9, this actually is 18. And you just want to keep going around the triangle. This side, look at the 8. So if this is 8, this is double that, this would be 16. And then this one here goes with this 5. Double that would be 10. So perimeter is going to be 10 plus 16 plus 18, which is 10, 20, 30, 44 units. All right, number 3. We've got same thing again, but this time we're finding the measure of angle LOQ. LOQ, right here. Okay, so we've already talked about how any of these lines from like this inner triangle to outer is parallel. What if I extend this one and this one? Then this would be called my transversal. So if this is 49 right here, what's this one gonna be? Block out everything else. If this one's 49, what's this one gonna be? Also 49. These are corresponding angles. Think of it, it's below my parallel, above the diagonal. That's the same place of this one. Below my parallel, above this diagonal. So it'd be 49 degrees. Number 4 looks a little different than what we've had. M is the midpoint of JL. So this and this would be equal. N is the midpoint of KL. So this and this would be equal. If MN, so right here, is 5x plus 5, and JK is 36 minus 3x, what is the measure of MN? So this same property occurs where when I have a midsegment, or this line is the middle of these two sides of the triangle, I know that 2 of these will equal this, or half of this equals this. I would rather have the 2 of the shorter ones. I don't like the fraction, but I'm gonna have 2 of the 5x plus 5 lengths would equal the 36 minus 3x. Distribute the 2, so that we get 10x plus 10 equals 36 minus 3x. Add my 3x, be 13x. Go ahead and subtract 10 to save room here. That would be 26 divided by 13. X would be 2, but that's not what they asked. They want the measure of MN. MN is my 5 times x plus 5. So 5 times 2 is 10. 10 plus 5 is 15. And if I plugged 2 in here, 3 times 2 is 6. 36 minus 6 is 30. So that would make this 30 and this 15, which is the relationship I wanted. This double that. And one more, same thing. If we've got a midpoint and a midpoint, so this is called a midsegment. If measure of angle OMN, so right here, I'm gonna have to draw an arrow in there. It's too little for me to write. Is negative 42 plus 8x. And OPQ, so right here, is 9x minus 50. What is the measure of OMN? So I have to plug it back into this one. So look, this is my line of my big triangle. Here's my mid-segment. These are parallel. This is my transversal. So hopefully you can see that these two angles are corresponding. They're in the same spot. And that means they're going to be equal. So what do I want to do with the expressions? Set them equal to each other. Subtract 8x. Add my 50. So that'd be x equals 8. Okay, plug that in to my negative 42 plus 8 times 8, which is negative 42 plus 64. 64 minus 42 would be 22 degrees.